Solving trigonometric equations. So let's start by graphing f of x as sine of x. We know that the period is 2 pi. It's got an amplitude of 1. It starts at 0, 0. It ends at 0, 0. Halfway in between is at a 0. At the quarter point, it's at a max. At the 3/4 point, it's at a minimum. Everybody got the graphed? Okay. Given the solutions of the equation, find where sine of x is equal to 1/2. How many places does that occur? There's 2 places where it occurs, right? And what we'll find is that the sine happens at pi over 6 and 5 pi over 6. So what if we're looking at not just in the range of 0 to 2 pi, but we're looking at all of sine, which is infinitely long in both directions? How many places would sine of x have a value of 1/2? Infinite. But they're regular. It's pi over 6, 5 pi over 6. What's the next one? Nope. 7 pi over 6 is right here. Isn't it just the next cycle? So it's this plus 2 pi. And then plus another 2 pi to this one. And then plus another 2 pi to get to the next cycle. So we could say that this value extended through all values. In other words, if we're looking from negative infinity to infinity, is pi over 6 plus 2 pi k, where k is an integer. What does an integer mean? A number, right? A digit, not decimals, not fractions, just a digit. Or 5 pi over 6 plus 2 pi k. And this is the way we're going to have to be writing these things for this particular piece of the unit. You got to recognize that this answer cycles and happens again and again every 2 pi. So we'd say 2 pi k. So take a look down here at number 1. How do I solve this equation? What I've got is 5 times this cosine of x thing plus root 2 is equal to 3 times this cosine of x thing. Okay, subtract 3 cosine x. If I've got 5 of them over here and I subtract 3 of them, I now have 2 cosines of x plus root 2 equals 0. Subtract the number, the constant. Divide by 2. And I get cosine of x is negative root 2 over 2. So now I want to think about where my solution is for this. I can look at my unit circle and figure out this is one of the 45s. For cosine to be negative, it's either going to be this one, which is 3 pi over 4, or this one, which is 5 pi over 4. But notice that it's asking me to find them from negative infinity to positive infinity. So I got to add on these wraps of 2 pi k and 2 pi k. All right, what about this one? Subtract 2 root 3 from both sides. Okay, so 3 tan theta. We'll subtract this equals 6 root 3 minus 3 tan theta. Add 3 tan theta gives me 6 tan theta equals 6 root 3. Divide by 6. tan theta is equal to root 3. Now I need to check my unit circle and figure out where tan theta is root 3. This is a positive value. Tangent's positive in 1 and 3. And I want the opposite to be the root 3 over 2. Adjacent is that. So this is pi over 3. Well, it could also be in this quadrant, couldn't it? And since I'm going from negative infinity to positive infinity, I could have said pi over 3 plus 2 pi k, but then I also would have had to recognize that it could also be, what is this? 1, 2, 3, 4 pi over 3 plus 2 pi k. And it turns out that tangent only has a period of pi, as we've talked about. So I can actually express this as pi over 3 plus pi k, not 2 pi k. And that'll capture both quadrant 1, quadrant 3, quadrant 1, quadrant 3, quadrant 1, quadrant 3. Why don't you guys try number 3 now, please? Do that one yourself. So if the cosecant is 2, then the sine is 1/2. How are we feeling about trig equations? 5, these are easy. I can solve these. 3, I have a shot at these. The little extension of 2 pi k is throwing me off. 1, I'm confused. Okay. Hands down question?
Could it also be higher than x? Or would it? Oh, sorry.
Yeah, it could be. Okay, let's do number 6 together. How do we start this one? Are you guys comfortable like just blocking this out as though it's one big variable? In other words, we're treating this algebraically as 4 times x plus 8 equals 11. Subtract 8. Divide by 4. And then we can substitute back in what x was, which was sine squared of u. Right, this is squared. So the way I undo that is by square rooting both sides. When I introduce the square root, what happens? Good, plus or minus root 3, and the square root of 4 just becomes 2. And now this time it's giving me a very clear domain restriction from pi to 3 pi over 2. So if I'm going from pi to 3 pi over 2, I'm not in 1, 2, or 4. I'm only in quadrant 3. And I'm looking for where the sine is a root 3 over 2. That's the tall triangle. And so this is going to be 4 pi thirds. It tells me here.
Oh.
All right, let's take a look at number 7. How do we solve 7? If we need to, what we can do is we can plug it in like some other variable. Let's say we're already using x, so let's say y minus 1. In other words, we're isolating that cosine squared x is now equal to y for us. And now it's, sorry, we don't want cosine squared though, because we want this to be 4y squared.
This is squared.
Good. Difference of squares. Do you know how this factors?
Yes.
I'm glad Ari does, but to the rest of you, you should recognize this as the difference of squares. This is 1 times itself. This is what squared? 2y. So in other words, the difference of squares says that I can factor this into 2y plus 1 and 2y minus 1. Now I can come back and plug in what I wanted. 2 times the cosine of x minus 1. That part could equal 0. Or 2 times the cosine of y plus 1 could equal 0. Remember, when we have two factors multiplied together to make 0, one of them must be 0. So I apply the 0 product property. And now I say the 2 times cosine of x is equal to 1. So the cosine of x is equal to 1/2. Or 2 times the cosine, that's supposed to be an x, equals -1. So cosine of x would equal -1/2. And I envision where that would happen. For cosine to be positive 1/2 is over here. That's those tall ones. That's going to be pi over 3. Oh, good. It doesn't require the 2 pi k because it's only from 0 to 2 pi. And that means this one would be 1/3 less than this full cycle. So 5 pi over 3. And then for the -1/2, I'd have 2 pi thirds and 4 pi thirds. Should go inside of 5 pi thirds. That way I'm expressing them in a nice clean order, which is always preferable. Yeah, what about number 9? Is this a confusing looking start? So let's take tan u and call it x. So 3x squared minus root 3x equals 0. What would you do with that? Factor the x out. And then we'd say, okay, this is the 0 product property. I've got two things multiplied together to equal 0. So either the x is equal to 0 or the 3x minus root 3 is equal to 0. We can plug this back in or we can solve this first. So that would mean 3x is equal to root 3. So x is equal to root 3 over 3. But x is really tangent of u. And so in the region from pi to 3 pi over 2, I'm looking for my solutions that satisfy either of these. So here's pi, here's 3 pi over 2. So I'm not looking at those. I'm only looking in here. Where's the tangent 0? This is -1 comma 0. This is 0 comma -1. Which one gives a tangent of 0? Pi or 3 pi over 2? Good, because it's y over x. So that means u is equal to pi. Where am I going to find root 3 over 3? Do we know that it's either the short triangle, the 60-degree triangle, or the tall triangle, not the middle one, not the 45? Is this fraction greater than 1 or less than 1? Do you guys agree that the square root of 3 is smaller than 3? So as a fraction, our numerator is less than our denominator. This fraction is less than 1. That means that when I do my opposite over hypotenuse, my opposite side has to be smaller, excuse me, opposite over adjacent, my opposite side has to be smaller than my adjacent side. So I know that this is going to be my 7 pi sixths. Because that's the only region we're looking for, those are our two answers. Do you see how important algebra is in here? Let's do number 8. Why don't you guys try number 8 yourselves, please? Having moved everything over to one side, so it's set equal to 0, I see that cotangent can be factored out of both. What do I get?
Sine squared x minus 1.
Almost. 1 minus sine squared of x, right? Oh, did you move it to the other side?
Yeah.
Yeah, okay, that works. Now I've got the zero product property again. Either the cotangent of x equals 0, or 1 minus sine squared of x equals 0. For the cotangent to equal 0, cotangent, and we're in pi to 2 pi, so this bottom half. For the cotangent equals 0, we need to have the adjacent over the opposite. Adjacent over the opposite. So it's here at 0, -1. So x is equal to 3 pi over 2. Then over here, I can get 1 is equal to sine squared of x, square root both sides. And I get that the sine of x equal to plus or minus square root of 1, which is still 1. Okay, so it's plus 1. Sine is the y value, so it's the same value, isn't it? So in this quadrant, the only value that's a solution is 3 pi over 2. Any questions on that one? Okay. So I'm going to express something that is probably not going to make you real happy. Early on, I found that you guys were being overwhelmed by homework. I found the homework pretty traumatic. Apparently that hasn't been good for you, because you're not getting as many practice problems. And so when you're getting to the test, you don't have as much familiarity with the content as you're supposed to. So I'm going to stop reducing the homework. That means you're going to have more homework. It means you're going to build more capability with this stuff. So when you take the tests, you will have seen these problems before. It will improve your grades, but it is going to be more work. So I've now gone through a little more than half of last night's homework. Those of you that didn't do it, that gives you half of that night done. And I'm going to give you another set of the same type of questions, more trig equations for you to solve. And over the 3-day weekend, I'd like you to work on those, so that when we get to this next test, you guys will have seen all these. It won't feel as unfamiliar to you.